Assalamualaikum students, I'm here with another question. This is question 3 from May-June 2003, question paper 4, mechanics in 1 for AL, kinematics. Basically we are doing kinematics, constant speed, okay, constant acceleration, moving objects with constant. Okay, yes. Now this question is given to us. Diagram is given to us in this question. In some question they ask us to make diagrams and diagram, and here diagram is already given to us. The diagram shows the velocity time graph. Velocity time graph I have told in the first question, that the questions which we are doing here, they are basically velocity time graph questions, and this has been done in IGCSE mathematics. Same concepts, the same rules are used here. Okay, so for the motion of two cyclists P and Q who travels in the same direction along a straight path, both cyclists starts from rest. One is starting from here, the other one is starting from here. Okay, at the same point O, and both accelerate at 2 meter. Acceleration for this object is, this cyclist is 2 meter per second square, and for this one also 2 meter per second square. Now they accelerate at 2 meter per second square up to a speed of 10. This is speed 10 meter per second. Both then continues at a constant speed. Here is constant speed, and it's 10 meters per second. Okay, I have told you that constant speed is parallel. The diagram will be we will show it on graph parallel to the x-axis. Okay, Q starts his journey t seconds after P. Now if P is starting at 0 second, Q is starting at 0 plus t seconds. If P is starting at 2 seconds, then Q is starting at 2 plus t seconds. Okay, that's the rule. They say that Q starts his journey t seconds after P. Now I will be making this thing more clear and in next steps. Now see, show in a sketch of the diagram the region whose area represents the displacement of P from origin at the instant when Q starts. Look here, displacement is basically the distance covered. Okay, distance covered here by P when the Q is starting its movement. Now Q starting its motion here, so just go from this point, make straight line. So this is the point where Q starts motion. So when the Q starts the motion, they say show in a sketch of the diagram the region whose area represents the displacement of P. This is the distance covered by P when Q started its motion, its movement. So this distance was already done by, covered by cyclist P. So they want this thing. Yeah, the first part done, and we got 1 mark here. Now given that P has traveled 16 meter at the instant when Q starts, find the value of T. Now this is T basically. Okay, they say that when Q started its motion, its movement, P or its journey, P already traveled 16 meters. So let's do this part 2. Part 2 I'm doing here. Total distance traveled by P is 16 meters. Now this is triangle, so 16 is 1/2 base into height. So 1 over 2. Base is what? T. Height is what? That's unknown. They say, let's say we call it look here. Okay, they given here basically this is V. Now see here, okay, let's say it's V here. Now I'm finding this V first because we can't have two unknown things in one question. So let me first find this thing. Where's my cursor? Come here, man. Just wait. Yeah, it's here. Look here, first I'm doing this thing, this height. Height is not with me, I'm finding the height. Now how to find the height here? Look, height, this is speed or velocity. I'm giving velocity here, V. Now you know this thing is representing acceleration. This is acceleration. So acceleration is 2 meter per second square. So the rise is V and run is T. So V gives us 2T. It means this value is 2T. Now 16 is equal to 1 over 2 T into 2T. So 32 is equal to 2T square and 16 is equal to T square. Okay, then we come here, we take square root. Here is my cursor. Yeah, so T is equal to 4 seconds. So this T is coming here. They were asking for T, so we got the value of T, 4 seconds. Now here this was velocity. Okay, this velocity. Now what we do here now, next part, well, our next part is part 3. In part 3 what they say, part 3, the distance traveled, the distance between P and Q when Q speed reaches 10 meter per second. Okay, yes, the distance between P and Q when Q reaches 10 seconds. Okay, how to do this part? Come on, think how to do this part. The distance between P and Q, distance, like I say this is P, this is Q, so this is the distance between P and Q. This is required. Now how to find this distance? What is the total distance traveled by that P? Then what is the total distance traveled by Q? Come on, if you find a total distance traveled by P and total distance traveled by Q, you can subtract them and you can get the value for the difference between them. So how to find the total distance traveled by P? First get that thing. Now see, what if we find this T? Okay, what will be the value? This is what? This is 4 seconds. Now how to find this thing? Come on, who will tell me how to find this value, which is here, this one, this, let's say T2. Yeah, how to find this T2? Who will help me in this finding this T2? Total distance traveled by P till here was, this was basically 16. Now this total distance, or this is the total distance traveled by P till here. Now how to find this point, this T2? how to do for this. What is the technique for this? Come on, think. What to do here? I want to get this T2. Come on, let's be simple thing. How to find this T2? Oh, let me tell you. This is what? This is acceleration. Okay, gradient. Is it 2? 2, yes. Acceleration is 2 here. Rise over run. Rise over run. So 2 is, what's rise here? 10. What is the run here? T1. So T1 is the run here. So 2 T1 is 10. So T1 is basically 10 over 2. So I got T1, which is 5 seconds. So this is 5 seconds. This is 5 seconds now. Now they say, look at the statement. Both then continues at a constant speed of 10 meters per second. Q starts his journey t seconds after P and same acceleration. So if this is P is reaching here after 5 seconds, this will reach here after how many seconds? Come on, 5 plus t, because they say, I told you previously that I will explain to you what is the meaning of this thing, how to do this thing. Q starts his journey t seconds after P. So if this is reaching here after 5 seconds, this will reach here for after 5 plus t seconds, which is 9 seconds. So this point is 9 seconds. Now come on, find the total distance traveled by P. They both were moving with constant speed then. Okay, constant speed. So parallel line with to the x-axis. Now P reaches here. So I'm just coloring this for P, the whole for P. Please find this whole distance. Come on. This is the distance traveled by P, the whole red area under the graph, the red area. Distance traveled by P is 1 over 2. Now from here to here, this is one parallel side, this is the other parallel side. So that is 9 minus 5, which is 4, and the other one is 9. What's the height? The perpendicular height is 10. So I got here, I think 2, 5 and 13 into 5 is 65 meters. Distance, now what I will do, I'm changing the color here. Yeah, distance traveled by Q is this rectangle. Distance traveled by Q is length into width. Length into width. Length is how much? 9 minus 5 is 4 into that thing, which is the height, which is 10. So result is 40. Distance between P and Q is 65 minus 40, which is 25 meters. That's the result. Thank you so much. And this is question number 3 I did. Now after this question 3 is given in the paper. I solved 3 questions. Okay, this is my third question, although also written over here 3, but this 3 is from this paper. Okay, inshallah I will be coming with more questions. This is number 3rd question. I'm doing some more to make you ready for your exams and for your tests. Okay, thank you. Allah Hafiz.